And welcome everybody to the Daily Space Weather, where we go in depth, we don't talk nonsense, and we look at El Sol and various other related geophysical phenomenon. Here is El Sol. We've got two pretty significant sunspot groups and one pretty minor sunspot group that looks like it's evaporating. The minor one is this one up here. This one's alpha class now, but it's pretty significant. And the most significant sunspot is this one right here. It's got the most complex fields. Let's have a look. Here's a colorized magnetogram. And this is the one to keep an eye on. And when I say eye on, well, the pun is intentional. That one right there. That is the one most likely to produce significant solar flares. Also, our CME watch for coronal mass ejections that we put up yesterday has not expired. The South Pole current sheet is here also. We'll get to it in a minute and show you a visualization of that. The 10.7 centimeter radial flux, the most proportional data set to sunspot number, still only at 73. So there's the 1 year chart to put that in context from Solon.info. The black line's the radial flux. And a space weather enthusiast dashboard not showing any NOAA alerts for geomagnetic storms or unrest. And we saw a little bit of an uptick in solar activity. We saw a major uptick in seismic activity. So just about 2 weeks ago, we saw an 8+ magnitude quake here off of Alaska. And now we've seen a 7+ magnitude quake at Haiti. So here's a location of that. There were some tsunami concerns associated with this. No tsunamis initially reported. This earthquake did cause loss of life and major injury and damage. At least 29 killed by this quake and 1,800 injured at least. Many, of course, going missing. This article, coincidentally, from the U.S. Sun. So there was a tsunami warning briefly issued. I didn't see any reports or anything like that of any significant tsunamis. So let's check the list here over the past 24. There was also a 6.9 magnitude quake on the southern Alaskan peninsula. That one came in at 11:57 yesterday, and thanks to our viewers and our patrons. Shout out to Mary Wright for telling me about that one. There was also a 5.4 at the Mid-Atlantic Ridge, and this Haitian quake occurred at 12:29. So only a half an hour after that large quake in Alaska. Large quake up here, large quake down here in only a half an hour. So that's a bit of an uptick, I'd say. And of course, we have countless aftershocks in both of those areas. Also a deep quake at Tonga. That one nearly 400 kilometers estimated depth and a 4.5 magnitude. That would be like a 5.5 magnitude if it was at the surface. But it wasn't at the surface, was it, Blanche? So I'm going to keep the list scrolling pretty fast here. If we miss anything, please leave it in the comments. Deep quake at Argentina at a mid-4 magnitude range. And I'm going to go back to the bar graph for just a brief moment here. South Sandwich Islands region also continues to shake there with mid-level 5 magnitude quakes and a series of high-level 4 magnitude quakes. Also this one here, another 5.8 there, an aftershock at Haiti. And they're a deep quake at a 5.4 magnitude at Peru. The depth of that estimated to be just under 100 kilometers of depth. And all I can say about this area on the bar graph is let's hope none of those are foreshocks. I'm not anticipating that they're foreshocks, but they could be foreshocks, and if they are, that would be bad. Let's see what volcanoes are erupting as we see some new ones on the list once again. Some usual suspects returning to the list as well. Karimsky remains on the list, exploding like it was yesterday, producing an 8,000-foot ash plume over Kamchatka, 15,000-foot ash plume over that peninsula from Shivaluch volcano, Cherinkatang in the northern Kurils south of there in between Japan and Kamchatka. No volcanic ash identifiable in satellite imagery. Fukutoku, Okinawa. No idea if that's erupting or not in the volcano islands. Nishinoshima. Continuous observations in satellite imagery showing a 7,000-foot plume of volcanic ash and explosive activity. Semisa in the Aleutian Islands exploding. Low-level eruptions are enough to produce a pretty high plume of ash. Flight level 100. It's a 10,000-foot volcanic ash plume over the Aleutian Islands. Popocatépetl exploding. 20,000-foot ash plume over central Mexico. Fuego in Guatemala producing a 15,000-foot ash plume as it explodes. Revenador exploding. Similarly sized ash plume there, flight level 150. Sabancaya exploding. Flight level 240. It's a 24,000-foot plume of volcanic ash. And we're unable to detect Nevados de Chilean. Please do not pole vault the caldera. This public service message brought to you at massive personal risk and expense from smAsho.com, where subscription services are coming in September. So join us in welcoming others to the Neo-Renaissance. Once again, congratulations on finding our YouTube channel. You can find our social media links there, as well as smAsho merch. And if you click on that, it'll send you to this page, where we'll show you today's featured merch. So check that out. Today's featured merch is the Mensa hat, since it's up to you to make Earth not suck again, not giant heaving bureaucracies that can't even get out of their own way. Mensa, make Earth not suck again. It's up to you. Not incredibly ineffective, overpaid hack frauds to make Earth not suck again. So pick one up. You can find a whole bunch of other products there with the same design at the Redbubble shop. You can also find the Mensa, make America not suck again. Somebody making our lives not suck as much is our patrons. So thanks to all of our patrons. Patreon.com/smashamash if you'd like to help support our cause. Lots of other links below the video as well. Please visit them. Looking at solar flares here over the past 3 days, we don't see any major ones except for, well, this C-class flare. That's sort of major. But in the past 2 days at least, nothing major in the solar flare category. The likelihood of solar flares has gone up with that beta-class sunspot. Nothing noteworthy happening in the proton flux. No surprises there. And the GOES magnetometer is looking spiky here over the last about 6 hours. And that's because Earth has snapped into a South Pole current sheet, most likely, as we forecasted. And here's the top view ecliptic plane field plot. Keep in mind the data here is over 6 hours old, and Earth is most likely already snapped into this South Pole current sheet. You can see Earth potential field surface source line there in orange. This is, by the way, stereo A, and this is, by the way, stereo B. They have magnetometers which contribute to this data. We'll also show you the line of sight ecliptic plane field plot, and you see some swings of the B field here shown by this blue line, essentially. Some magnetohydrodynamics going on there. And the coronal hole line of sight plot. I just want to reiterate that over the next 60 days we can expect to see a major and precipitous uptick in coronal holes. So we've already seen two transequatorial ones, this pretty weak North Pole-oriented one, and now we see a South Pole-oriented one also, which did not show up on yesterday's data. Coronal hole forecast is for a major uptick. So we just put up a still image here of the detected sunspot groups. Sunspot 2857 is the one to keep an eye on. The other ones are a little bit less active. Also keep in mind it is in the Earth-facing quiet effect zone, so the likelihood of major solar flares Actually, not really that high, although we could see some evolution of those sunspots. We'll keep you posted on the channel. And you can see the likelihood of solar flares going up here, as we stated earlier in the video. KP index currently at 3. We're expecting to see this drop down as the BTBZ has started to come out of negative territory. It's another coronal hole wind stream as we see a sputtering series of coronal hole wind streams. Let's take a look at the real-time solar wind. And you can see once again we saw this downtick in the solar wind density and this uptick in the solar wind velocity. So it looks like another coronal hole wind stream to me. Current conditions are 436 kilometers per second for the solar wind velocity, solar wind density 4.07 protons per cubic centimeter. Actually, it has snapped back into pretty strong negative BZ territory here. And that top image is the total field strength. So the total field is the BT, and that's in nanotesla. And the BZ is the polar contribution to the field. So when you see negative, you're seeing a contribution of 5 nanotesla from the south solar polar field, and in this now we're at 6 and 4, so 2 nanotesla from the north pole and 4 nanotesla from the south pole to make a total field of 6 nanotesla. And it's a pretty weak coronal hole wind stream so far. It looks like it may have already peaked. Next, looking at magnetohydrodynamic pressure. It's our geospace magnetosphere movie. And if all goes well, it's going to show 4 hours of data. Looks like a subsiding coronal hole wind stream to me. What do you think? Let us know in the comments. Do you have a forecast? Let us know in the comments. We're interested in your forecast, especially how you arrived at your forecast. Next, ground magnetic perturbations. Changes to Earth's own B field. Also giving you insight into what's going on with the polar excursion. Location of auroras. Location of likely power outages in the event of a geomagnetic storm, which we don't see at all. And we're going to actually show you the auroral forecast after this. Like the last frame, this was 4 hours of data. And it's a model from the Space Weather Modeling Framework. So here's the auroral 30-minute forecast. And we should see a little bit of an uptick here. Since we saw an uptick in ground magnetic perturbations, we expect to see a small uptick in the aurora as well. And as we approach an equinox, the likelihood of auroras and geomagnetic storms goes up a bit. As the solstices are the least geo-effective portion of the seasons. Anyway, no major auroras. By the way, once again, thanks for viewing the videos. Congratulations on realizing the existence of our channel. Please don't forget to press like and subscribe if you enjoy the content. Tell your friends, foes, science noobs, and science pros about us. We are unconfident that the algorithms are doing so. So please share on your social media. We're also on BitChute. More exclusives coming there soon. Here's a diagram of the solar system. If you're wondering where stuff is, Earth is swinging past Jupiter as it dominates the night sky. There's where things will be in a week. It looks like a full moon will fall on the 22nd. Here's a star chart. And you may see Jupiter and Saturn. They've already set here in Lehigh Valley, Pennsylvania. We've also drawn in the ecliptic plane. The sun the path will take across the sky. The path the sun will take across the sky. And we've also put in the galaxy plane and the shading of the galaxy to give you a little bit more insight into astrography or whatever you're into. It's in-the-sky.org. Today's cosmology segment's integrated. Check the other cosmology segment playlist. There are over 200 videos on there. We're going to look at cosmic rays real quick, as this is an important aspect of space weather. You'll think it's even more important coming soon. And no more on that, but here's the current state of affairs at Uptick. And Uptick actually showing an uptick here over the past 30 days. Small uptick there at Uptick neutron monitor. How about Barentsburg? A small uptick there, a little smaller, but still an uptick nonetheless. Let's go farther south to Athens, Greece. So here's the Athens neutron monitor. Also showing an uptick over the past 30 days. That's what weak solar activity will do, or will it? Next, Mexico City's Cosmic Ray Observatory. More significant uptick there. So cosmic ray uptick here at so far 4 of 4 cosmic ray monitors. Looks like a legit uptick in cosmic ray flux. Oulu, Finland showing flat over the past 30 days. DOMB Antarctica, a small uptick there over the past 30 at least. And DOMC Antarctica showing a similar uptick over the past 30 days. So that's a legit uptick in cosmic ray flux, folks. Continuing on with the cosmology segment, why are the Perseids called the Perseids? Because they emanate from the constellation Perseus. So here's a great time-lapse image of lots of Perseids. And you can see how they emanate from a central point. And this great imagery is the NASA astronomy picture of the day by Luo Hongyang. Well done. Nice artistic imagery there of quite a lot of Perseids in an area with very low light pollution. And the constellation of Perseus is right on the galactic plane, if you're wondering. Today we haven't picked a random number at all. We're just showing you the X-ray transient hard X-ray output. The hard X-ray output from Cygnus X3. It remains in a quiescent state. Here it is over the past 30 days. And remember, folks, this is X-rays, not cosmic rays. This is photons. Cosmic rays are protons, primarily hydrogen nuclei. Anyway, you can see the way X3 has been sort of centered over the past 30 days on this 0 line. Way down here, it remains in a quiescent state. And we implore radio astronomers to sight this thing in when it goes back into an excited state, or preferably before and during its ramp up to a more excited state. Cygnus X3. That's our cosmology segment. Again, check our playlists. There are like 200 plus videos, like 220 videos or something like that in our cosmology playlist. YouTube.com/smashamash/playlist. We are seeing some satellite charging hazards here, and these surface charging hazards could cause some communications breakdowns. It's probably not Russia, it's probably not China, and it's probably not Nibiru. It's certainly not Nibiru, and it's certainly most likely not Russia or China. They're experiencing the same problems you are, communicating with satellites, perhaps. So if you see some minor communications breakdowns, it could be from that. Typically caused by electrons, and here's a 1-year chart of the earthly electron flux. That's the electron flux at the F ionosphere layer. We'll show you a visualization of that in a minute. And here is the 3-day chart of the electron flux. NOAA forecasting an uptick in this, and I would tend to agree. Actually forecasting a downtick first. And I would tend to agree with that also, as we are seeing, once again, another coronal hole wind stream. Here's a diagram of Earth Van Allen belts, just to give you an idea of what we're looking at. The total air column is all the way up to GPS satellites, located at about 12,500 miles of altitude. And this total electron content forecast gives you an idea of where GPS errors are most likely to occur, but more importantly, it gives us insight into the structure of Earth's magnetic fields. Electrons are only about 1/1800th of the mass of a proton. In other words, 1,800 times as light as a proton. And when we see anomalies in the electron content, it gives us insight into Earth's magnetic fields, as those electrons are the first thing to align to the fields. Anyway, things looking fairly organized there. Here's another diagram of the atmosphere to show you where the F ionosphere layer is, because we're showing you that next. Here's the F ionosphere in megahertz, millions of vibrations per second. There's a lot of chemical reactions and vibrations going on up there above your head at about 300 kilometers of altitude. That's the altitude of the F ionosphere layer, approximately. And we're seeing some low-frequency anomalies here. Quite a bit of low-frequency anomalies. We'll show you on the next frame. Quite a bit of low-frequency anomalies happening here. And rather than try to explain where they are, I'll just bring up the latest image. That's from 10:45 Universal Time. Here is the anomaly imagery. This is anomaly in megahertz from the 30-day median or mean. You can see some low-frequency anomalies over North Africa, around the South Atlantic anomaly, which is now over the South American continent. Pretty much the entire area around South America seeing low-frequency anomalies, and some low-frequency anomalies over places like northern Canada as well, and northern Siberia. And here's the latest image from 10:45 Universal Time. You can see those low-frequency anomalies over northern Canada. By the way, we're going to do a meteorology segment today. If you would be a follower on Twitch, you may have gotten a notification about it, and you may have seen the video before anybody else, twitch.tv/smAsho. Why not download the mobile app if you'd like to see the latest meteorology updates and so on? Join us at twitch.tv/smAsho. It's the ultimate live streaming platform. Twitch.tv, it's completely free. Wouldn't you prefer to see the videos first? We're not trying to get you away from the YouTube channel. We're just trying to expand everybody's horizons. Our meteorology segments are fresh, yo. Check them out, yo. They are fresh. Here come bonus features. Here's bonus feature number 1. It's the Lermonth, Australia ground-based solar observatory, and see some significant prominence up here. This could be our coronal mass ejection watch becoming a coronal mass ejection warning. We may have to make another video about that later in the day. Check out all the filaments. You can see a filament down here in a prominence form. These dark areas are also filaments. Keep an eye on sunspot 2857, is it? I think that's the sunspot. I do not commit these things to memory. And also here at the end of the video, you can see a little bit of Nibiru or perhaps some Borg spacecraft moving in between the observatory and the sun. Here's the NASA GOES 16 Workhorse SUVI thematic map. Don't forget our coronal hole forecast. In the next 60 days, we're expecting to see a major uptick in coronal holes. There is a coronal mass ejection watch in effect. We'll be looking later to see if it's become a warning. Here come additional bonus features. We're going to press refresh for you. There's the latest high-res imagery. And that sunspot still is beta class. That one is alpha class, and I think those are the only two groups that are going to have names by the end of the day today. Here's a colorized magnetogram. We'll press refresh on that. And you can see opposite polarity umbrae. This is north, this is south, making it a beta class sunspot. There's my block letter. And we'll close out the video on 2 more SDO animations here. This is composite imagery. 2 ionized iron emission states. That's 211 and 304, 211 and 171 angstroms. 304 angstroms is ionized helium. We'll zoom in on the northern hemisphere, as it's where the action is currently occurring. And here's 131 angstroms. Thanks again for tuning in, and may that solar wind be at your back.